The approach that we've adopted with using the padlock to control access to the balance variable is a completely valid approach, but there is a different approach which is also available to us when operating on variables of primitive types. So essentially, let me get rid of this and let me get rid of the locking instructions here, and we can change the balance differently because there is a certain class called Interlocked which can actually perform certain operations atomically, and it just so happens that one of those operations is changing an integer by adding or subtracting a number. So let's take a look at how it works. Now, Interlocked, if I just bring up the code completion window on it, you'll see that it has a couple of methods like add, compare, exchange, decrement, increment, memory barrier, read, and we'll discuss some of them. So at the moment, what we're interested in is we're interested in the add method because that's what takes a value and adds it to a variable in an atomic way. It has to be stressed, it's done in an atomic way. However, you can see that it takes a ref argument here, and unfortunately we have an automatic property without an explicitly accessible backing field, and because you don't see the backing field, you cannot do a ref to it, unfortunately. So if we just alt enter here and we change it to a property with a backing field, we now have a backing field called balance with a small b, and that's what we can use for the interlocked function. So to increase the balance by the amount, instead of saying balance plus equals amount, we're going to do something different. We're going to say interlocked.add a reference to the balance field as well as the amount. There we go. So that's going to be what we're going to do for deposit, and for withdraw it's the same thing. You'll notice that interlocked does not have a subtract method, but you can just do interlocked add, say ref balance here. So say ref balance once again, and here we'll just say minus amount. That's all that we need to do to subtract. So now that we're using these, essentially it's similar to what we had with the locking, but we're doing this using this rather more direct mechanism, so-called lock-free programming. Okay, so let's run this, and you can see that the final balance is once again 0, and we can run it a couple of times just to verify that it sticks at being 0. So this is yet another approach. Now let's talk about some of the other functionality that's available in the interlock class. Essentially, we have increment and decrement. That's basically increase by 1 and decrease by 1, so fairly obvious stuff. We also have something called a memory barrier. Now, a memory barrier is actually just a shorthand for something else. It's a shorthand for thread.memory barrier. Now, I'm not sure this is the right place to mention it, but let me explain or try to explain what memory barrier is all about. Now, one of the problems with concurrent code is that sometimes the CPU can actually reorder instructions which are written as you write them. So essentially, let's suppose you wrote 3 things. You wrote maybe you wrote something, then you wrote something else, and then you wrote something else. Now the problem is that you probably expect these to execute as 1, 2, and 3, whereas the CPU can execute them as 3, 1, and 2, for instance. So what the memory barrier does is it basically tells the CPU that in no instance can the instructions that appear before the memory barrier be executed in the block after the memory barrier. So that's the goal of the memory barrier here. That's something that's also tied to the volatile keyword. Okay, so that's something that the interlock does, but interlocked has 2 methods called exchange and compare exchange, and these are in fact used for thread-safe assignments and thread-safe comparison. So we have exchange, and what exchange does is it basically sets the value. So it assigns the value, for example, a floating point value to whatever you specified, and then it gives you back the original value. And both of those things are also happening as an atomic operation. And then there is something called compare exchange. And what compare exchange does is it basically compares 2 values for equality, and if they are equal, then it replaces the first value. So once again, these are not a complete set of operations that will let you do any code in a thread-safe fashion, but it does give you a few options in terms of programming without locks and still having this kind of functionality.